So welcome to the class on probability. In this class we will be seeing about discrete and continuous probabilities. Mainly our focus will be on continuous probability from here, and we will understand what do you mean by either. Okay. Now what do you mean by a discrete event or a continuous event? Okay. First we have to understand that. Now what do you mean by a discrete event? Example, let us say throw of a dice. What all you can get? The sample space can be 1, 2, 3, 4, 5, 6. Correct? You can never get 1.1 in a throw of die. This is ruled out. You can never get 2.7 in a throw of die. This is ruled out. Correct? Okay. Similarly, we will say that we are drawing a card from a pack of cards. What will you get? You can get 1, 2, 3, anything up to king. 1 means I mean the ace. 2, 3, anything up to king. Okay. Of 4 suits. That is hearts, clubs, spade or diamond. You can get any of these, any 4 suit, these cards. Correct? You can never get a card called 2.4. You can never get a card called 2.4. You can never get a card called 4.7 like this. These are ruled out. This is what is a discrete event. Okay. Now, what do you mean by continuous event? We have to understand this very clearly. And by the way, what is the probability here? Probability of E is nothing but N of E divided by N of S. Okay, now what do you mean by continuous event? Let us say I am estimating life of a battery. Okay. Now the battery can work for 3 hours. Correct? Say it works for 4 hours. It can also work for 3 hours, 30 minutes. It can work for 3 hours, 30 minutes, 30 seconds, 30 microsecond, like this. So, in short, what I am trying to say is the battery life can take any number between 3 and 4. For example, if I am saying between 3 and 4, it can take any number. Just 3 and 4 are the numbers I have assumed. It can take any number. So, here the numbers are discrete, whereas here it can take continuous. In this case, it was discrete, whereas in this case, it is continuous. Continuous means what? It can take any number between 3 and 4. With respect to this example I am saying. With respect to this example, it can take any number between 3 and 4. That means it can take 3.1, it can take 3.01, it can take 3.001, it can take 3.0000001. So, if we discuss in this range, what is the number after 3? What is number after 3? Is it 3.1? No. Is it 3.01? No. Is it 3. If you say this is the number after 3, I will say 3.0000. I will add 100 more zeros and put 1. And if you say that is the number after 3, I will put few more zeros after that and say one more 1. So, number after 3 is not known. Correct? You don't know what is the number after 3. It is not 3.1. It is not, because it is continuous. What is the number after 3 if you say 3.0001? If you say this is the number, I will write few more zeros after this and say this is the number. Is this the number? No, this is also not. You can put after this also you can put few more zeros. So you don't know. Similarly, what is the number before 4? It is not 3.9. Is it 3.99? 3.999? Like this 9 keeps on going. There is no end to it. So we don't know what is the number before 4 also. Correct? So how many numbers exist? Between 3 and 4. Between 3 and 4 we have infinite numbers. Correct? So if I say that my event is going to give output between 3 and 4. Okay, so this is my sample space. So if I try to evaluate what is the probability of getting 3.5, I am asking you. Always when you let us do a continuous experiment, then when you do an experiment, you can get any number between 3 and 4. It can be 3.1, 3.2, 3.001, 3.999, 3.878, something, any number. So there will be infinite numbers. And I am asking you what is the probability of getting 3.5. 3.5 is one number. So n of e will be 1. N of s will become infinity. So probability of e will become 0. Correct? This is one classic case. Second case, I am asking you, okay, I am asking you now do the experiment will give you any number between 3 and 4. Okay, now what is the probability of getting a number between 3.3 and 3.4? This is the question. Between 3.3 and 3.4, how many here between 3 and 4, how many numbers exist? Infinite numbers exist. Between 3.3 and 3.4, how much numbers exist? Here also infinite numbers exist. Correct? Because between 3.3 and 3.4, you can have 3.3000001, 3.30000000001. Like that, you can keep on writing this. So here also infinite numbers exist. Here also infinite numbers exist. Now if I try to evaluate probability of E as n of E by n of S, we will get infinity by infinity. This is much worst case. Clear? So both of them we have problem. We have problem. We cannot evaluate what is the probability. So we have to find a way out. Find a way out. This is what is the problem with continuous probability. In discrete probability, this scenario does not exist because you know how many entries are. N of S is finite and n of E is also finite. So in discrete case, we don't have this problem. Clear? Fine. So now we are going to deal about continuous probability distribution. It is really interesting. So P of E, the first conclusion is P of E equal to N of E by N of S is meaningful only in discrete events. And it loses meaning in continuous sense. Continuous events. This is a very, very important conclusion. This is very important. Okay, this is a very important point. Clear? So, how we are going to deal it? So, okay, now let us play one game here. It's something like a archery game. Okay. This is my bullseye. Archery. We are trying to play archery. Okay. Now, this is my event. Let me say that this is my event. Okay. And this one, this entire thing is my sample space. This entire thing. This entire thing is my sample space. Now, how many in continuous sense? N of E is also infinity. N of S is also infinity because how many points are there? Infinite points are there in sample space also. Infinite points are there in the event also. Correct? I am trying to count how many points are there. Correct? So if I try to evaluate probability of E, it becomes meaningless. But observe, area, if I treat this as a area of E and S are finite. So I can call probability of E as area of E divided by area of S. This is a finite value. Correct? This is a finite value, and definitely area of E is a proper subset of S. So this value will be less than 1 and it is meaningful in probability sense. So this is how probability is defined in continuous sense. So this is how probability is defined in continuous sense. So we are no more going to talk in terms of n of E by n of S, rather we are going to talk in terms of area of E by area of S. This is the idea of continuous probability. Correct? So the moment I say area, how can I get the area? Integration gives the area under the curve. Correct? Integration gives area. So I can define a function called, a function can be defined such that the total area is always 1. Correct? That means what? Means what? Area of S is 1 always. Then area of E is nothing but probability of E, because area of S here is 1 always. I am going to define a function like this. Okay, I am going to define a function like this such that area of S means what? It can take all values. So integration for all that value is 1, whereas integration that means area of E will become probability of E. Such a function is called the probability density function. Clear? So we are starting with the probability density and probability distribution functions. Clear? So what we saw? We are talking about continuous probability. Okay, what did we see? We are going to define probability of E as area of E divided by area of S. Area can be achieved by integration, and I am going to define a function such that area of S is always 1, and such a function is called the probability density function. That is, area of S is net area under the curve is 1 means what? Everything from minus infinity to infinity, f of x dx is 1. F of x is a probability density function. So whenever I say probability density function, this property should alarm in your mind. This is the very important and powerful property of probability density function. Integral minus infinity to infinity f of x dx is equal to 1. So whenever there is a density function, this property will be applicable. So it is very important. So whenever density function comes, automatically you should be, this should get triggered in your mind. Clear? Fine. Then, now what do you mean by integration? I am going to write some very important conclusions here. What do you mean by integration? What do you mean by integration? Integration is nothing but accumulation, correct? You keep on accumulating, correct? Yes or no? So, you are accumulating some quantity continuously. From infinity, minus infinity to plus infinity, you are keeping on accumulating the values of f of x dx. Now, accumulation of infinite quantity is a finite one. That's what this statement means, right? If I write in English, that's what this statement means. Integral minus infinity to infinity f of x dx is 1 means what? I am accumulating the value of f of x from minus infinity to infinity. That is, I am accumulating infinite values of f of x, but still the sum is a finite one. How can this be possible? How can this be possible? How can this be possible? You are adding infinite numbers, but you are getting finite number as a result. How can it be possible? It is possible only when we start adding zeros on either side. Correct? That means what? Say for example, let me draw some graphs here. Hey, this was by the way important. This was asked once in GATE. Okay. So please pay attention. See. So let me take three cases, case A, case B and case C. Now I am going to integrate it from minus infinity to infinity. Let me say it is going to be like this. It becomes 0 here. Now let me take another case here. Like this. Now can this be, let me call this as f1 of x, f2 of x, f3 of x. Okay. Let me say this is x minus x minus x x minus x x. Now this is going towards infinity, minus infinity. This is towards plus infinity, correct? Minus infinity. This is going towards plus infinity. This is going towards minus infinity. This is going towards plus infinity. Okay. To avoid confusion, let us separate this out. We have three functions here, right? Okay. Now let us analyze. Now here, if you see, I am adding zeros here. If I do 0 to infinity, definitely if I integrate between 0 to infinity, I will get a finite area because this is becoming 0. So this area is finite. No problem here. But what will be the problem here? It settles off to a constant value. It is not approaching 0. Not approaching 0. Now, this value, let it be even 0.01 also, very low value, but it is not 0. Now, having said it is not 0, if you add even 0.01, 1 crore times, the value will blow up. It cannot be a finite one. So, this value will, integration here will blow up means what? It will diverge from 1. It will not converge towards 1. So, f1 cannot be a probability density function. Okay. Why it cannot be probability density function? Because the moment I say probability density function, this property must be satisfied and your f1 cannot satisfy that property because it is not converging to 0. If it is not converging to 0, you are keeping on accumulating some finite value. Keeping on accumulating finite value, the value will cross 1 at some point of time. So, this cannot be a probability density function. Similarly here, if you see, it is converging towards 0 on this side. So if you integrate it here, it will give you a finite value. So integral minus infinity to 0 is not a problem. Whereas in this region, it will be an infinite value. Why? Because it is not coming towards 0. This is not equal to 0. So since this is not approaching 0, this value will blow up and integral minus infinity to infinity f2 of x dx will be greater than 1. So f2 of x is not a probability density function. Now let me take a function something like this. Don't worry about the shape. Let it be any shape. But it is approaching 0 here. It is approaching 0 here. It is 0 here. It is 0 here. Now you see, this is a finite value. This is a finite value. And this area and this area can sum. I am not saying will sum. It can sum and give me a value 1. But this and this can definitely not give me. These two can definitely not give me a finite answer, whereas this can converge here and here and give me a value 1. So f3 of x can be a probability density function. So please remember, the moment I say probability density function, it should approach 0 on both sides. If it is not approaching 0 on both sides, I am not saying it should exponentially approach 0 or it should abruptly approach 0. It can approach 0 anyway, but it should approach 0 in both the sides. If it is not approaching 0, you will be ending up in something like this or something like this, and it will not be a probability density function. So please remember this concept. It's a very important point and it is very useful for gate. Rather, this was once asked as a gate problem also. So what is our first important result? We have so far seen two important conclusions. First important conclusion is minus infinity to infinity f of x dx equal to 1 if f of x is a probability density function. Second conclusion is what? If f of x is a probability density function, then f of x has to approach 0 on either side to satisfy 1. Else, let me write this in red, 1 will fail. That is, 1 means property 1. 1 will fail and f of x will no longer be a probability density function. Okay, so these two are like the lifeline now. Wherever we go, these 2 points are continuously going to follow us till the end of probability class from here. So please remember this. Clear? Then, now let me draw a probability density function. Let f of x be a probability density function looking something like this. I am not bothered about the shape. It can be anything, but it has to approach 0 on either side. Okay. Now, let me take 2 points called A and B. This is minus infinity. This is going towards infinity. This is x 0. Okay. Now, I am going to observe some points here. Okay. Now, if I integrate from minus infinity to a f of x dx, what it will give me? It will give me this area, correct? It will give me this area. So what is this means? X is taking some value between minus infinity and a. That's what it means, correct? Yes or no? That means integral minus infinity to a f of x dx is nothing but probability that the random variable x, whose probability density function is given by f of x, is less than or equal to a. Okay. What do you mean by a random variable? This is x. See, x is a random variable. First, let us understand what do you mean by that. A random variable means it is a variable which cannot take certain values, which cannot take any value with certainty. That means there is some uncertainty in the value taken by capital X, and that certainty or uncertainty is what is given by your f of small x. Clear? Capital, see, for example, small f of x is your random variable such that the bulb will work for 3 hours. Okay. So small f of small x is the density function which describes the behavior of the bulb, and probability that capital X, that is the life of bulb, is less than or equal to 3 hours will be given by minus infinity to 3 f of x dx. Clear? So capital X is a random variable, small x is a variable which describes the behavior of capital X. Clear? Fine. Now we got this. Now I am going to ask you one more question. Integral, what will be integral minus infinity to b f of x dx? This will be nothing but this area, correct? It will be nothing but this area. The one which is shaded in that light blue color. Okay. So this is nothing but probability that x is less than or equal to b. Now I am going to ask you one interesting point here. What is this area? The one what I am currently shading. What is that area? That is nothing but integral minus, not minus, integral a to b f of x dx. This is nothing but probability that x lies between a and b. Correct? Okay. Now similarly, what is this area? Let me take different color. What is this area? This area is nothing but probability that x is greater than b. Correct? This area is nothing but probability of x taking a value greater than b, and probability of x greater than or equal to b is given by integral b to infinity f of x dx. Correct? Yes or no? Now what do we know? Now you see how I am going to link the concepts what we studied. What do we studied in our basics of probability? Probability of E is nothing but 1 minus probability of E complement. Correct? Now what will be probability of x greater than or equal to b? Probability that x is greater than or equal to b is nothing but 1 minus probability that x is less than or equal to b. Correct? Yes or no? Correct? Then, so what you will get here? It is nothing but 1 minus integral minus infinity to b f of x dx. So these two are same. Integral b to infinity f of x dx is same as 1 minus integral minus infinity to b f of x dx. Correct? This what is the property of probability density function, right? Because if I add these two, I will get integral minus infinity to infinity f of x dx, that is nothing but 1. Correct? So I can find probability of x greater than or equal to b in this fashion or in this fashion. So we have arrived some important results here. Each and every result here is very important. Please remember these things. Okay? These three results are very important. Clear? With this as introduction, we are going to proceed ahead now. So this is our problem here. Let f of x be a probability density function of random variable capital X given as follows. So f of x is equal to cx in the region 0 to 2 and 0 else, and c is a constant. C is a constant. The value of c is not told to us. Okay. Now two parts are there in the question. Find the probability that x is greater than or equal to 1. Part B is find k such that probability of x less than or equal to k is 0.9. These are the questions asked. So how to solve this? Okay, let us take now what is given in the problem. What is given? Given that probability of f of x, first thing is a probability density function. F of x is a probability density function. What should strike your mind? Integral minus infinity to infinity f of x dx equal to 1. Now c is unknown. Correct? In the given problem there is something called c that is unknown. Using this, let me say this as 1. Using 1 we can find c. How? Because integral minus infinity to infinity f of x dx is 1 implies integral. I am going to see how the function f of x is defined. The function f of x is defined in this fashion. F of x is taking cx in this interval and everywhere else it is 0. Correct? That means what? It will be, I can split this as minus infinity to 0 plus integral f of x dx plus integral 0 to 2 f of x dx plus integral 2 to infinity f of x dx. In this part f of x is 0, so this becomes 0. In this part again f of x is 0, this becomes 0. So what will we get? We will get integral 0 to 2. In this part what we will get? In this region, in the region 0 to 2, f of x is given by cx. Correct? Cx dx, and this should be equal to 1. Correct? Because this value is equal to 1, so this should be equal to 1. This is what it implies. Implies what we will get? Integral 0 to 2 cx dx is 1, means c is a constant, I can take it outside. X on integration will give me x square by 2 between 0 to 2 is 1. Correct? So what will I get? Implies c is what? C is, if I substitute the lower limit and upper limit, I will get 4 minus 0 by 2. 4 minus 0 by 2 okay, is equal to 1, or c is nothing but 1 by 2. This is what is I am getting as the area. Value of c. This is what is the value of c. Correct? So c is 1 by 2. Now having found the value of c, we have to go and solve now part A and part B. Correct? What is part A now? What is part A? Probability that x is greater than or equal to 1. What is probability that x is greater than or equal to 1? We just now derived this relation, right? We just now derived one result, right? Probability that x is greater than or equal to b is nothing but integral b to infinity f of x dx. So this is nothing but integral probability that x is greater than or equal to 1 is nothing but integral 1 to infinity f of x dx. So it implies that integral 1 to infinity can be split and written as integral 1 to 2 plus integral 2 to infinity f of x dx. By the definition of our given f of x, in the region between 0 to 2 only f of x exists. Correct? In this region only, else everywhere it is 0. So this part becomes 0 and this part is what I have to evaluate now. So this part is what I have to evaluate. That I am doing it here. So integral probability that x is greater than or equal to 1 is nothing but integral 1 to 2. F of x is nothing but cx. We found the value of c as 1 by 2. 1 by 2 into x dx. 1 by 2 is a constant, so that can be brought outside integration. And integral of 1 to 2 x dx. This is nothing but 1 by 2 x square by 2 between 1 and 2. This is what I am getting. Clear? We will solve this now. So I am solving the part A here. Probability that x greater than or equal to 1, we saw that, right? It is half x square by 2. Correct? Between the limits 1 and 2. So when I substitute the limit, I will get half of 4 by 2 minus 1 by 2, which is nothing but half times 3 by 2, that is nothing but 3 by 4. So probability that x is greater than or equal to 1 is 3 by 4. So this is the solution for part A. Now part B is what we have to solve. What is part B? Find k such that probability that x is less than or equal to k is 0.9. Now we studied just before that, probability x less than or equal to k, how it will be given? Integral minus infinity to k. f of x dx. We derived this, right? We analyzed this with the help of graphs and we understood this, right? So minus infinity to k, f of x dx is nothing but probability x less than or equal to k. Correct? Now, this integral can be broken as integral minus infinity to 0. I am always breaking up like this because that's how my f of x is defined. F of x is defined in the interval only 0 to 2. So integral minus infinity to 0 f of x dx plus integral 0 to 2 f of x dx plus integral, I will break it like this, plus integral 0 to k. Okay, plus integral 0 to k f of x dx. Correct? That's how we have to break it now because we don't know what is k. So the value is 0.9. So integral minus infinity to k can be broken as minus infinity to 0 f of x dx plus 0 to k f of x dx. We don't know what is k, so I cannot write integral k to infinity because k to infinity we don't know what will be the value, and that is not needed also because we have to integrate from minus infinity to k only. I am not integrating from minus infinity to infinity. Correct? So this is what we will get. So in this part f of x is not defined, so we will get 0. In this part I am going to get some value. So what is f of x? So probability that x less than or equal to k is nothing but ultimately it boils down to integral integral 0 to k f of x dx, and I know this value as 0.9. This is given to me in the problem itself. I need to find the value of k. Now what is f of x? F of x in this region is nothing but half x because c is half. F of x is cx, c is half, we found it out. So it will be half x between 0 to k. So 0 to k half x dx is 0.9, implies x square by 2, 1 by 2 is a constant that will stay outside. X on integration will give me x square by 2 between 0 to k is 0.9. If I solve this, what will I get? Half k square minus 0 by 2 equal to 0.9. So k square is nothing but 0.36. Correct? Yes or no? Correct? K square is 0.36. Are we solving the problem correctly or did we make some mistake? Half x dx is 0.9, implies half times x square by 2 between 0 to k is 0.9. It's nothing but half k square minus 0 by 2. This is 0.9. So k square will be 0.9 into 4. Correct? So 0.36. 0.9 into 4 will be k square will be 0.9 into 4. Correct? I think it will be 3.6. Sorry, it is 3.6. So k should be root of 3.6. That will be what? Root of 3.6. Correct? So root of 3.6 will be 1.897. This is what I am getting. So probability that x less than or equal to 1.897 is 0.9. This is what was asked to me. So the value of k is 0.897. This is the solution for part B. Clear? I hope that part A and part B both are clear. Both are different models. Understand that in one case the value was given to us and we were asked to find the probability. In other case the value of probability was given to us and we are asked to find the value of x, the limit on x. Correct? So probability x less than or equal to 1.897 is 0.9. This is the solution. Clear? So this one is another quick problem we are going to solve. F of x is a probability density function of a random variable capital X, and f of x is given by 0.75 into 1 minus x square between minus 1 and 1, 0 else. Find probability of minus 1 by 2 less than or equal to x less than or equal to 1 by 2. So what it is looking like? Let us solve it. Solution. So let us solve it. Now this given structure is looking something like probability of A less than or equal to X, okay, less than or equal to B. Correct. So, and what did we find this as in our discussion? Probability A less than or equal to X less than or equal to B is nothing but integral A to B f of x dx. Correct. I'm sorry. Nothing but integral A to B f of x dx. Therefore, probability that minus 1 by 2 less than or equal to x less than or equal to half is nothing but integral minus half to plus half f of x dx, and in this region f of x is given by what? Minus 1 by 2 to plus 1 by 2, 0.75 into 1 minus x square dx. 0.75 is a constant, so I will bring it outside the integration. 0.75 into minus 1 by 2 to 1 by 2, 1 minus x square dx. This is nothing but 0.75 into, on integration 1 will give me x square will give me x cube by 3, between the limit minus half and plus half. So this will give me 0.75 into 1 by 2 minus 1 by 2 the whole cube divided by 3 minus 1 by 2 minus will become plus minus 1 by 2 the whole cube divided by 3. Correct? If you substitute the values, what will you get? If you substitute and simplify the values, what we will be getting will be approximately 0.688, or this is 68.8%. This is the probability that x will lie. This is nothing but what? Probability that minus 1 by 2 less than or equal to x less than or equal to half. This is what it means. Clear? Okay, we will solve one more problem. Let x be the random variable which describes the thickness of the part produced by a machine. Its density function is given by f of x, which is nothing but kx in the region 0.9 mm to 0.9 mm less than x less than 1.1 mm, 0 else. Okay. What is the probability that the thickness of the part produced is between 0.95 and 1.05 mm? It is what? This mm is unit because it's a length, it's a thickness. It has to take the unit of mm or some meters or whatever it is. So they have given this mm. So don't worry about this mm. This mm is just unit. We are to calculate the probability. The story still remains the same. So f of x is given to us. F of x is given to us. We are solve solution. F of x is given to us. How the f of x is given? It is kx in the region 0.9 less than x less than 1.1, 0 else. Clear? Now we have to find first, it is similar to the first problem, only the wordings are different. Okay, so first thing we have to find the value of k. How will you find the value of k? What is given to you? This is a probability density function. The moment it's a probability density function, integral minus infinity to infinity f of x dx is 1, implies integral minus infinity to 0 f, here it will be 0.9 because it is defined between 0.9 and 1.1, right? So 0.9 to 1.1 f of x dx, between 0.9 to 1.1 f of x dx, plus 1.1 to infinity f of x dx. I am breaking this region and this should sum up, this value should sum up to 1. Here it is 0, here f of x is 0. So ultimately we will get integral 0.9 to 1.1 f of x dx is 1. F of x is nothing but here kx. So k into x from 0.9 to 1.1 dx equal to 1, which implies k into x square by 2 between 0.9 to 1.1 is 1. On simplifying, we will get what we will get? K into 1.1 square minus 0.9 square divided by 2 equal to 1 implies what we will get. What is 1.1 square? If you simplify this, 1.1 square will be 1.21 minus 0.81 divided by 2 equal to 1. Simplifying, we will get the value of K as 5. This is the value of K. Now we got the value of K. Now we have to solve the problem. What is asked? What is the probability that the thickness of the part is between 0.95 and 1.05? Means what? Probability that 0.95 is less than equal to x is less than equal to 1.05. So this is nothing but integral 0.95 to 1.05 f of x dx. This is nothing but what? F of x is kx, right? So k is 5. We found it just here, right? K is 5. So it will be 5x between 0.95 to 1.05 dx. So this will be 5 is a constant, x square by 2 between 0.95 to 1.05. So when you substitute the limit, you will get it as 5 by 5 1.05 square minus 0.95 square. This should be the answer. When you simplify, what we are getting? When we simplify, what are we getting? So this is nothing but 1.05 square minus 0.95 square divided by 2 into 5. So it will be 0.5. So the probability that x lies between 0.95 mm and 1.05 mm is 0.5. This is the answer. This is the solution. Clear? Fine. Okay. So now I am going to introduce another terminology to you called probability distribution function. Now this is given by capital F of x. This is defined as integral minus infinity to x small f of x dx, where small f of x is the density, probability density function. Clear? Means what? F of x is nothing but the accumulated value of small f of x. We have already seen what you mean by the accumulated value of small f of x. Means what? Probability that x is less than or equal to x. Correct? Yes or no? See, what do you mean by probability of x less than or equal to a? This is nothing but integral minus infinity to a f of x dx. Correct? Now I am keeping on varying this a and finding the value of minus infinity to a. I am continuously varying a and finding the values. So it will give me a function. As a varies, this value, this integral will give you different values. Now that can be plotted as a function that is called capital F of x. Correct? Now what can be, now the important point what you have to understand here is x less than or equal to a f of x. This is nothing but capital F of a. Clear? Where f is the distribution function. Okay? Now how will the distribution function look like? How will it look? It will look like how it will look. It will start at 0 and end at 1. Correct? What is capital F of x? Capital F of x is nothing but integral minus infinity to x f of x dx. Correct? Now, what is the maximum value of this integral? Even if I integrate, I know f of x is what? F of x is not some function. F of x is a density function. I know that integral minus infinity to infinity itself is 1. So, f of x can never go more than 1. So, f of x will always start at 0 and end at 1. Clear? This is how f of x will look. It will always start at 0 and end at 1. So, this is a very important property of a distribution function. This was again once asked in a gate problem. How will okay, let us solve that problem itself. See what it is telling. Okay, before solving that problem, let us see one more property here. If this is the way f of x is defined, so what will be? I am trying to write something here. Please pay attention. This is a different way of understanding capital F of x. Capital F dash of x is nothing but small f of x. Correct? If integral of f of x is capital F of x, differentiation of capital F of x should give you small f of x. Correct? Yes or no? That means slope of f dash of x is given by small f of x. Correct? Yes or no? That's because differentiation is nothing but will give you the slope of the function. Correct? And how is small f of x? Small f of x will start at 0 and end at 0. See, now I am trying to draw the corresponding density function here. Density function will always start at 0 and it will grow something and end at 0. This is how small f of x will look. Starting at 0, ending at 0. Correct? Now, the slope here is 0. That means what? The function cannot grow here. Because slope has become 0. Slope is only when slope is changing, the function can change the value. Only when there is a only when there is a non-zero slope, the function can change the value. Correct? But that means slope of capital F of x is 0 here also. Slope of capital F of x is 0 here also. That means this will be constant here. Slope is 0 means the function will be constant. Correct? So here it is 0. And here also the slope is becoming 0. That means the function will take a value constantly, that is 1. It cannot grow more than 1. Correct? So 0 to 1, it will get, at 1 it will get stagnated. Between 0 to 1 it will grow. And this side it will be 0. So capital F of x will grow from 0 to 1. Small f of x will grow from 0 and then come back to 0. That's how it is. So now this is a gate problem actually. It was asked once in gate. This is my f of x. Okay. This is my f of x. Okay. How will capital F of x look? Okay. This is one gate problem. Now I am least bothered about these values. Don't worry about these values. Let this be some a, b, c something. Now, see, this is a linear region having a positive slope. This is a linear region having a negative slope. Linear region, correct? This is a straight line, that means linear region, correct? Here slope is positive because the function is rising. Here the slope is negative, correct? And what is this slope? This slope is nothing but the slope of the capital F of x, correct? That means what? The capital F of x will have, if you integrate this line, if you integrate a straight line, what will you get? You will get a parabola, correct? You will integrate a straight line, you will get a parabola. So the parabola will look something like this. And if you integrate this straight line, see, this is something like minus x, this is something like plus x. Correct. If you integrate x, you will get x square. So that is like a parabola. It will be something like this. Similarly, this is like the other function, the other side. If you integrate this, you will get the parabola on the other side. So you will get something like this. Correct. So this is how your capital F of x will look. That's it. This is a gate problem. This value will be 1. This value will be 0. It will start from 0. It cannot go below 0. Okay. It cannot go below 0. It will start at 0 and end at 1 like this. This was once asked as a gate problem. I hope this problem is clear now. Is this clear? Fine. So let us have a concluding remark of what we saw in this session. We saw what do you mean by continuous probability. In continuous sense, the probability is defined as, probability of E is defined as area of E divided by area of S. Correct? And then because n of E by n of S becomes meaningless, then we saw what do you mean by a density function. Density function is nothing but integral minus infinity to infinity f of x dx has to be 1. This is a very important property of density function. Based on this, we proved that it has to start at 0 and end at 0. Correct? Because we are accumulating infinite values, still we want to get a finite one. That means it should start at 0, end at 0. Then what we saw? Integral minus infinity to a f of x dx is nothing but probability that x is less than or equal to a. And similarly, integral b to infinity f of x dx is nothing but probability that x is greater than or equal to b. Then integral a to b f of x dx is nothing but integral a less than, probability that x is between a and b, that is a less than or x less than or equal to b. And then finally we came to distribution function. Distribution function means what? Distribution function is nothing but capital F of x, and it is defined as integral minus infinity to x small f of x dx. So capital F of a, meaning of capital F of a is what? Probability that x is less than or equal to a, and that's what we saw, integral minus infinity to a f of x dx. That means what? This value is nothing but f of a, and this value, what will be integral a to b f of x dx? It is nothing but f of b minus f of a is what is the meaning of this. And then the distribution function will start at 0 and end at 1. These are the very important properties, and using this relation integral minus infinity to infinity f of x dx equal to 1, if f of x is having some constant term which is not told to us, we used this relation to find what is that constant term which is not told to us in the problem, and we can solve it. Clear? Fine.